All right, so I'm going to go through a few of these problems. The first one, you deposit $2,200 in a bank account. Find the balance after 4 years for each of the following situations. So question 1, the account pays 3% annual interest compounded quarterly. So I'm going to use the compound interest formula. There's more than one way to do this or set as far as variables go. But we're trying to find the final amount. Let's see. The initial principal was $2,200. The 1 represents 100%. Our growth rate is 3%. Notice I divided that by 100 before I put it in here, so 0.03. Compounded quarterly, there are 4 quarters in a dollar. There are 4 quarters in a year. And then what is T? Right here. It's also 4. We're finding the balance after 4 years. So that's a coincidence. When typing this in, I like to just type it in all at once. So 2,200. I'm going to use the alpha y equals button to make sure I type in that fraction properly and make sure my calculator follows the proper order of operations for this problem. If you have an older calculator, you may need to insert some extra parentheses here. Typically for money problems, they want us to round it to the nearest cent. So $2,200 is now turned into $24.79 and 38 cents. Really the only difference in this next problem, I won't work it all out, but just to make sure we're clear, our rate is 0.015, and we're compounding yearly, which means we're compounding 1 time a year, so n is equivalent to 1. All those other numbers, t is 4, the initial principal is the same, so it's really exactly the same way. This one, same thing. Compounded monthly means n is 12 months in a year. And our rate is 0.0225. Shouldn't really have any problem with those, but if you do, reach out to me and let me know. Compounded continuously. Just remember we're using a different formula when we compound continuously. A equals P times E raised to the RT power. There shouldn't be any surprises there. Let's look at a question you have to work backwards. So when this one wants to know how quickly can 450 turn into 1350. So that means we know our A, and we know our initial principal. Since we're compounding continuously, that means we're using this formula. So 450 times E raised to the rate, which is 0.025, times the time, and ultimately that's what we're trying to come up with. How long will it take? So we want to solve this for t. Okay, so I'm going to divide both sides by 450. I want to get the e by itself. I think that's 3. But let me just double check. Okay. So we have 3 equals e raised to 0.025 times t power. Since it's e, we need to take the natural log of both sides. we know the natural log of e is equivalent to 1. So ultimately, we're going to be left with, after using that third logarithm property, where this exponent can move out to the front, and the natural log of e disappears because the natural log of e is 1. And now just a pretty simple divide both sides by 0.025. And let's let the calculator take the rest, natural log of 3, and immediately divide that by 0.025. All right, and then different teachers require different things here. Some say just round it to 2 decimals or 1 decimal. Let's see, did the directions say to 1 decimal place? So 43.9. Other people might say, so 43.9 ultimately is what you should put because that's what the directions say. But if they want to know how many years, full whole years it takes, an argument could be made that the answer is actually 44, because 43 years, it wouldn't get to that point. 44 years, it would be over that point, but we've at least reached that point. But let's just go with what the directions say, round to the nearest tenth, so 43.9. So let's look at a similar problem. You are saving for a purchase that costs $500. You have $200 deposited. It's a pretty similar setup. Only difference is different formula because we are compounding monthly. So no e this time. Using this formula, should be familiar to you. The rate is 0.05, and it's important, guys, that you show all of these steps. Or there's not a lot of steps to show on some of these problems, but you need to show the setup of the formula. We're compounding monthly, so that's where I'm getting 12 from, 12 months in a year. And we're trying to find out, again, how long. So we're trying to solve for t. I would encourage you to try to solve this one on your own first, but we divide both sides by 200. And notice, we want to keep the rounding to the absolute minimum here. Some say you may not want to round any, but so this decimal 1.04166667. So just round it off to 3 decimal places, but you don't want to just say that's 1, because that can affect your answer probably too much. Log both sides. I'm going to do kind of combined steps here. I log both sides and move the exponent to the front. And then simply, we want to get t by itself, so we're going to divide both sides by 12 log 1.004. So log 2.5 divided by, I'm going to divide it twice. So I'm going to divide it by 12 and then immediately divide it again by log. And the reason I'm doing that is because I didn't put parentheses around the denominator. So better safe than sorry. I'm guessing the directions are round to the nearest tenth. So that would be 19.1 months. And again, some would say the answer is actually 20, because at 19 months you don't have that amount, but at 20 months 20 full months, you definitely do. But directions say nearest tenth, so that's what we'll do.